Hello, folks. Let's continue our exploration of functional programming by writing a program. So we've set up a bunch of basic language constructs and syntax. So let's actually write a program. And so here's the goal of the program. We would like to write a program to demonstrate list membership. All right, so we want to know, is something the member of a list? So this is how it would work. So we're going to have a function called isMember. We'll pass in an atom, like the letter B. Is B a member of this list? A, B, C. Okay, and so this is going to return true because it is a member of the list. And then if we were to do isMember B, A, C, D, E, this would return false. So to be specific here, our goal is given an atom. Well, actually, it doesn't even have to be an atom. We'll just say given a value and a list, we're going to return true, value in list, and we're going to return false otherwise. Okay, so let's do a trace of how this algorithm might work, and then based on the trace, we will hopefully determine our algorithm. All right, so that's the idea anyway. So here's our first trace. isMember B, A, B, C. All right. So what we'll do is we're going to check to see, well, we're going to compare B and A, and are they equal? All right. So if yes, then return true. All right, if yes, then return true. Otherwise, if no, then we're going to do the following. isMember B, B, C. And then we're going to take B again, and we're going to take B, the first item in the list, and we're going to compare them and see if they're equal. So if we get yes, we're going to return true. And no, we're going to continue. But in this example, these two are equal. B and the first item from the list are equal. So we're going to return true. So that's a pretty straightforward example. Let's look at one that's a little bit more lengthy. All right. So isMember B, and we're going to check a list that has C, D, and E in it. So this time B is not present. Okay. So first we're going to check these two, and the answer is no, they're not equal. So then we're going to do isMember B, and we're going to check it against D, the list DE. We're going to check these two, And we get a no, they're not equal. So we'll do isMember again. B, E. These two are not equal. All right. So last isMember check here. And okay. So when we are doing an isMember of our value and we have the empty set, what we should do, that means we should stop, right? Means we didn't find what we were looking for. Okay, so we clearly have evidence here of recursion, right? We're going to have okay, so we've got two good models of recursion, and I think we've got a pretty good idea of what to do here, right? If we get a match between the value and the first item in the list, we're good. If we don't get a match, what we're going to do, we don't get a match, the answer is no. What we're going to do is we're going to reduce the size of the list and call isMember again. So let's just write that down as our algorithm. So our algorithm is if value equals the first element in the list, then we're going to return true. If list is empty, we're going to return false. Otherwise, we're going to call isMember with value and the rest of the list. So the rest of the list is the list, but with the first element in the list peeled off. And we already have a scheme function that will do that for us. All right, so this is a pretty good overview of what we want to do. And so now it's actually time to write the code. So what I would suggest that you do, given that we have talked about all kinds of available functions that you can use, is you know enough to get this algorithm to work. So why don't you take a moment, hit pause, take a moment, see if you can come up with an answer, and then you can check your answer against mine. Okay, so here's the code. So we're going to do a define isMember value and the list. All right, now these are the two parameters, value and the list. I didn't use the word list here, although it'd be tempting to do that, but it turns out that I think that's a reserved word in Scheme, so you can get into trouble in some versions of Scheme with that. So looking at this code for the algorithm, we've got a bunch of ifs and basically sort of like an else, but this really lends itself really well to a con statement. So that's what I'm going to do here. So I'm going to say cond empty Oh, I think I want to do it the same way that I wrote the algorithm. The order doesn't totally matter. Well, actually, it does matter because I think I actually want to check to see if the list is empty first before I check to see the value. That way, if the, the reason why is if you had the situation where you were doing something like this, you said isMember empty list A, B, C. What we don't want to do is we don't want to compare empty list to an empty list here, which will be the last thing that we check before we finish the method. If we compare this to the final empty list with all of these elements, A, B, and C removed, then we might think that this empty list and this empty list here was a member of the original list, which it's not. This is the empty list that's produced after we strip out A, B, and C. So this, if we check to see if the list is empty first, let's do that. So if we check to see if the list is empty first, we'll avoid that weird condition. But we also want to make sure that this is okay. We should be able to do isMember empty list, and that should return true. And that particular isMember will return true even with this con statement that we have here. Okay, so the next thing we're going to check is equals. And we're going to check value against the first thing in the list. So first, the list. Oh, yeah. So if value is equal to first in the list, we want to return true. Actually, let's put that here. We want to return true. Okay. And then the last statement is an else. And this else is we're going to call isMember again with value and the rest of the list. So that will strip off the first item in the list, and we'll have the rest of the list. All right, we're going to close the cond, and then we'll close the define. Okay, so with this code, let's just trace let's trace our examples and see what happens. Okay, so isMember B A B C. Okay, so let's trace this. So we call isMember with B, that's our value, and ABC is our list. So we're going to start out here, and we want to answer this question. Is the list empty? Well, no, the list is not empty. The list is ABC. So we're going to skip that. Next one. Is value, which is B, equal to the first of the list? Well, the first of the list is A, and the answer is it's not. So We're going to skip that statement. And then we're going to execute this else statement. isMember value rest list. So we're going to call, I'm going to clean up these marks so we can do tracing on the next one. So we're going to call isMember with value again and the rest of the list. So the rest of the list is what's left over when you pull off the first element of the list, so that's B, C. Okay, so let's trace it again. Is the list empty? No, the list is BC, so it's not empty. Is value equal to the first thing in the list? Well, there's value, B, and the first thing in the list is B. It is. So we're going to return true. Fantastic. All right, let's try running this again. So this time we're going to reset the code, and I'm going to do slightly smaller text, isMember B C D E. Okay, so when we run this, initially we're going to see, is the list empty? No, the list is CDE, it's not empty. Is value equal to the first thing in the list? Well, value is B, the first thing in the list is C, so the answer is no. So we're going to end up calling whoops. Let's get back here. We're going to end up calling isMember value rest list. When we do that, we're going to have isMember B D E. All right. And we're going to execute the code again. We're not going to get a match between B and D. So we're going to do isMember B E. And we're not going to get a match between B and E. So we're going to do isMember B empty list. So when we do isMember B empty list, the first statement we're going to check here is the list empty? The list is empty, so we're going to return false. So the end result of this is false. Awesome.